All right, in this video, we're going to have a look at how to find a sequence, or the formula, I should say, for a quadratic sequence. Now, before you do this one, you probably should take a look at the video we just did over here, the how to find the formula for a linear arithmetic sequence. If you know how to do this, the quadratic sequence will go a whole bunch easier. Okay, so let's make it nice and simple. So we're going to use the quadratic sequence. The first thing I think is to realize what a quadratic sequence is. So if I had a linear sequence, and in fact, let's say I've got 1, 2, 3, 4, 5, 6, and so on. If this was quadratic, we could make it quadratic. If I just call that n, we could make these n squared. So n squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, and so on. These would in fact be the square of these numbers here. So let's now have a look at a sequence that we're going to actually find the formula to. So let's take a sequence. In this case, I'm going to choose. Let's take a look at this now. What am I going to do? Hang on. I just can't see my screen. It's disappeared. Oh, it's too big. Hang on. Sorry, folks. Here we go. All right. So here's my sequence. I'm going to use the sequence, and I'm going to use. Let's see. What about 6, 19, 38, 63, 94, and so on. Now, before, when we did a linear sequence, or if you like, an arithmetic sequence, we looked at the differences between these, and we were able to use the difference in our formula, Tn equals a plus n minus 1 times d. Now, on this one here, we're looking at the differences. Well, here, the difference between these two is going to be 13. There it is. Difference between these two. Oh, wait, it's not 13 now, it's 19. So now I've got differences that are different each time. And that is the thing that makes this quadratic. Well, in actual fact, the difference that's going to make this quadratic, in fact, is going to be the fact that these now have a linear difference between them. So if I look at these two, the difference between theirs is 6, the difference between these two is 6, the difference between these two is 6. So here we've got changing differences. Here we've got the same. So in this fact, we've actually got a quadratic sequence. This is a linear sequence, and these numbers are all just the same. It's now a static sequence. So let's have a look now at the original sequence. We're going to go back to this, and now what we're going to do is have a look at the n squared terms for these. So let's make this nice and simple. Here we are. So here was the original sequence we had. We've got 6, 19, 38, 63, 94, and so on. Now, we had before n squareds, and in fact, I could actually write, if you like, the n squareds under here. So this is our sequence. Now, the n squareds are going to be, now if I have a look at this, I could just write 1, 4, 9, 16, 25, and so on beneath these. But before I do that, I'm going to want to take this difference here. Now, this difference here is a 6. And the one thing we know about the first term, we're going to have Tn is equal to something. The first term is going to be, the coefficient is going to be half that value there. So half of 6, so I could just write 6 on 2 if you like, times n squared. That's going to be our first term. And then we're going to have a whole bunch of things after that probably. Well, let's see how that's going to play out. So, first of all, I'm going to have, oh, by the way, and 6 divided by 2 is in fact 3. So here is my n squareds, and I could just write them out. I could just go, we're going to have some sort of a 1, a 4, a 9, a 16, and so on, yes? But what I could do, instead of writing an n squared here, I'm going to make that 3n squared. Well, 3n squared is just going to be 3 times that number. So let's have a look. So this, well, I'll leave that as n squared. I'll put my 3n squared right here. So my 3n squared is going to be 3 times that number. So because these were our squares, and this is going to be what, 25 and so on, yeah? So 3 times 1 squared is 3. 3 times 4 is going to be 12. 3 times 9 is going to be 27, and so on, yes? What have we got? 3 times 16 is going to be 48, 3 times 75 is 75, and so on, yes? So now what we're going to do is we're going to take the differences between those. So here we go. I'm going to make this a big minus sign here. I'm going to go 6 minus 3 is 3. 19 minus 12 is 7. 38 minus 27 is 11. 63 minus 48 is, what's that going to be? It's going to be 15, and so on. Now I have the final part of the sequence. So I've got one part of the sequence, which is Tn is equal to, and I had 6 on 2n squared. I'm just going to call that 3n squared, because 6 on 2 is 3. So 3n squared, there it is. And what's the rest of it? Well, here's my 3n squared part of the sequence. This gives me the rest of the sequence. And the rest of the sequence is going to be whatever that is when we use our formula. Now, we already know the formula for an arithmetic sequence. This is an arithmetic sequence, so I'm just going to write Tn for this part here. It's going to equal a plus n minus 1 all times d. The difference between there, 4 and 3, is going to be 4. Difference between those is going to be 4. These are all 4s, the differences, yes? So now the first term is a 3, so I've got t is equal to 3. There's my first term. Then I'm going to have n minus 1. Well, we don't know what n is yet, but we've got a d, which is a 4. So it's going to be times 4. So I've got 3 plus, well, 4 times n is 4n. 4 times negative 1 is minus 4. So Tn is equal to, this is for the arithmetic part, is going to be a 4n. 3 minus 4 is minus 1. So I got this part here, and I'm going to tack that part on to the end of this bit here. So now my final answer is going to be 3n squared plus 4n minus 1. There it is. So the final bit is going to be the 2 combined. So the final value of a particular term is going to equal 3n squared plus this bit here, 4n minus 1. And that is how we find the formula to a quadratic sequence. Now, there's a lot of different ways of doing this. I've been through a fairly involved way, actually, but yet this is probably the most common way which is taught today in classrooms around the country. So that's the first thing. I'm going to show you, if I can, a few different ways, and you can then choose the way which you find most useful. The other thing, of course, is to make sure you choose a way which your teacher will accept if you wrote those kind of workings, say, in an exam. So that's going to be important too. Hopefully that makes sense. You might like to try a few of these for yourself from maybe an exercise which you've been doing, and that's wildly out of focus. Can we get back in focus? Focus, 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 focus. Crikey, this camera, I've got to get a new camera. All right, hope that makes sense. Good luck, folks.